All right, the second topic for today, which is all about tables. So hopefully you remember what frequency tables are all about. So here, this is just a random example I've got. It's we've got some matches that have gone on, probably from football. There were there were 33 matches in total, and we've got in 12 of the matches there was 0 scored. In 12 of the matches, 1 goal was scored. 4 matches, 2 goals were scored. And 5 matches, 3 goals were scored. The reason why we use things like this is because if I was to write that out as a long list, there would obviously be like 12 zeros, and it's a bit time consuming to have that data. A table is far more efficient. Well, how about if I had a list of data that looked like this, the number of house points in a year? Why wouldn't I want a table like the one above to represent this data? Well, if I had a table like this, it wouldn't be much help. It takes up a lot of space, it's a bit cumbersome, and it's not particularly efficient like it was in that first example where it was useful to have that. So how could I do a table where this does perhaps look a bit better? Well, I could group them all up. I could say, right, for this first, I'm going to group them into different bands. I'm going to say, right, 0 to 10 points. I'm going to have the next one will be 11 to 20 points, 21 to 30 points, 31 to 40 points, 41 to 50 points, and I think I'm done there. And then I could just band them all together. So in that first category, 0 to 10, I've got 1 value. For 11 to 20, I've got 1, 2, 3, 4, 5, 6, 7 values. And I've filled the rest in there, and I would add up my frequencies and make sure they gave me 25 in total. We don't know what all those values are in those classes or in those boundaries here. We don't know what that one is. It could be 0 points or it could be 10 points, but which obviously stops it being completely accurate or giving us all the information in one go. But it does look, hopefully you'll see, a lot more efficient. So here I've got another perspective table of marks in an exam. Can you tell me what the issue is here with this table? So pause the video and have a think. Well, there are 2 main issues here. First of all, where am I going to put, for example, 30? Because if we look here, in this group here, I've got 20 to 30. Well, but in this group here, I've got 30 to 40. So do I put it in here or do I put it in here? We need to make sure these are really clear. So 0 to 10 will be fine, but the next one I would have to start at 11. Right, 11 to 20, the next one will be 21 to 30, and so on. Is there anything else wrong? Well, hopefully we spotted that there's a group missing. We haven't got, well, that would be 41 to 50. So we're actually missing something. I wouldn't be able to put all the information in here. Hopefully when I did all the frequencies, I would find out they did not add up to 24, so something had gone wrong. So we just got to be careful about these details, and what we'll see in a second, we need to make it very clear the distinction between what's going on here. Well, all the examples we've looked at so far, if you think about what type of data they are, they've all been quantitative because they've been numbers, and they've all been discrete. The number of marks in an exam, you get 2 marks, 5 marks. Yes, you might have a generous teacher, so you might get half a mark. However, you can't take it along. You can't have like a 4.29 mark or something along those lines. Same with house scores and things like this. So my question is, what if my data was continuous instead of discrete? So what might the issue be here to begin with? Pause the video and have a think. Well, the issue would be is this whole idea about continuous data is I can have any set of values along a range. So say, for example, this wasn't marks. Say instead this was, for example, time measured in seconds. Well, if I've got this time, so say if I've got 0 up to 49, say I've got, well, yep, I've got 9 seconds, that's fine. 9 seconds is going to go in here. I've got 10 seconds, that's great, that's going to go in here. And the next person measured kind of their time was like 9.5 seconds. Right, I'm going to put that. Oh, wait a minute. I've got nowhere to put it because here I've got 0 to 9. Here I've got 10 to 19. Well, this value here is in between. So I've got nowhere for it to go. So when we're doing frequency tables, grouped frequency tables with continuous data, we have to use a different technique. It's not too different, but there is some slight changes. Well, let's say we'll use the same kind of information as above. Let's see, this first one will go for, we want it to be from 0, and we'll say we want it to go all the way up to 10, but not quite including 10. How would I write that? So think about mathematically, how could I write that? So I want to go all the way up, super close to 10, but not quite there. Well, I don't want to say, for example, 0 to 9.99999 recurring. I don't really want to do that because there's still some discrepancies there. But what I could use are inequalities. I could say that t, representing time, well, it can be greater than or equal to 0. And we're going to go all the way up to 10, but not quite include it. So what symbol would I put in between there? Hopefully remembered, I would put this in. So that means it's less than 10. It can be so close to 10. It could be 9.99999 with a billion nines after it. So it's super close to 10, but it's not quite 10. Well, what would the next one be? Well, the next boundary would start off, that one can equal 10. And we would go all the way up to 20. So in there, I'm going to have 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 19.5, 19.6, 19.9999999, and so on and so forth. 10.34, all those values in between along that whole range are going to go into that there. And then hopefully we can start to notice the pattern. So 20, we could be equal to it, but we're going to be less than 30. And the next one, well, that one, it's fine to equal 30. But we're going to go all the way up to 40, but not quite be exactly 40, because 40 is in the next one. So now we have catered for every possible value we could put in. And put 15 there for completeness. So it doesn't matter what these values are. 9.3, well, that's going to go into this one. Okay, 10.02. Well, that's going to go into this one because it's slightly more than 10. 39.999 is going to go, well, it's less than 30 still, so that's going to go in here, and so on and so forth. So the key thing here is, for example, this is discrete data up here. So that's fine to have these values here because I can have 0 and I can have 9 and I've got nothing in between 9 and 10. Those are specific values. I can only take those, remember, I can only take like that value, the next value will be here, the next value would be here, and so on. I can't get anything in between, I've just got specific values. Whereas here for continuous data, because I've got anything along this range, I'm going to have to use these inequalities because I can get super close to 10 and then the next boundary starts and I go to 20 and so on and so forth. So let's have a look at a question. So this is the first question on that worksheet that I've given you. An airline company records the weights of the bags that passengers check in kilograms to one decimal place. So copy and complete this. Hopefully you've printed it. If not, just copy the table out and I want you to fill it in. So let's just get started. So 7.3 would go in here. That's between 6 and 8. There we go, 7.3. 8.2 is going to go here. 9.1 and so on and so forth. I would like to highlight here what modal class means, so please label this up on your worksheet or in your book. Modal class is just the class Do you remember what mode means? It's the class with the most in. So whichever one, I'm going to put in brackets, has got the highest frequency. Okay, so finish this question and have a go at the rest of that worksheet.